Welcome back to another M&S tutoring video, and in this video we're going to be learning about the covalent compounds and bonding between two nonmetals. So when two nonmetals want to gain and complete their outer shell to become virtually stable, they have to share their valence electrons, right? Compared to ionic bonding, where there's usually one metal that's willing to give and a non-metal that's willing to take, the same type of bonding doesn't really work with covalent compounds. This is because both of them are non-metals and they want to gain valence electrons to complete their shell. So they end up sharing valence electrons rather than giving one or taking one. And this, in return, is called a covalent bond. So covalent bonds, as I mentioned before, are brought together with two nonmetals. And just like ionic bonding, this happens because of the atoms wanting to be stable and because of the electrostatic connection two atoms have. So say for example you have hydrogen and oxygen. Hydrogen needs one valence electron to complete its outer shell, and oxygen needs two valence electrons to complete its outer shell. So how can hydrogen and oxygen, really like work together to create, to have both of them to have full valence electron shells? So the first thing you have to look at is the combining capacity. The combining capacity is the number of bonds a nonmetal will need to form to become a stable molecule. So as we looked at that before, hydrogen, the combining capacity, so we'll call it Cc number for now. For hydrogen, the combining capacity is 1. And for oxygen, the combining capacity is 2. Since oxygen needs a combining capacity of 2, we know that we need 2 hydrogen atoms. Hydrogen atoms to complete the valence, right? And since oxygen needs 2, we know that oxygen only needs 1. It needs 1 oxygen atom to complete the valence, right? The combining capacity is sometimes known as the octet rule, and this is where atoms tend to bond in such a way that will allow them to fill up their valence electron shell. It's usually called the octet rule because most valence shells are 8 electrons in capacity, but with hydrogen, there's an exception because hydrogen has the first valence electron shell of 2. So 1 oxygen atom to complete the valence, right? So now let's look at the hydrogen and oxygen atoms side by side. Let's draw the Lewis dot diagram. So for hydrogen, we have 1 valence electron. So I'll draw 1 valence electron. And for oxygen, we have 6 valence electrons, right? We have 1, 2, 3, 4, 5, and 6. So oxygen needs 2 electrons to complete it, and hydrogen, hydrogen only needs 1. But if we had 2 hydrogen atoms, which we could have it in this case, we could complete both hydrogen atoms and we could complete the oxygen atom as well. So to show the covalent bond, we would have to show links with both hydrogen and oxygen. So the first way we could actually show this diagram is by having H on one side and having one of the electrons of H with an X and O for a circle. And notice that I differentiated the oxygen electrons with the hydrogen electrons by using X's and dots. So, and then I have 2 over here and I have 1 oxygen here. So I need another hydrogen atom. So after I have another hydrogen atom, I can add the other X, and now I have my covalent bond. If another way you can show this bond is by showing lines. So say for example you have oxygen over here and you needed two hydrogens to complete this side over here and this side over here. So instead of actually drawing the dots or the X's, you could actually just draw a line connecting it to hydrogen. So you could have hydrogen here, and you could connect a line like this. Right? This shows that the valence over here is full, the valence over here is full, and the valence of hydrogen is full as well. Right? And those are the two ways you can show that you can show, and you can actually use covalent bonding to form bonds between two nonmetals. So the important thing to know here is it's between two nonmetals, right? Covalent bonds are formed when there are two nonmetals and they want to become stable. They want to complete their valence electrons. Now let's look at moreover how to name covalent compounds. And over here it gets a bit tricky, but if you really practice naming your naming these compounds, it'll become really third nature to you. It'll become really easy. So this really depends on the number of the nonmetals changed, the number of nonmetals used, and you use this to change the prefix. So if the first nonmetal is 1, then there is no prefix. So say you have, so first of all, you would order the hydrogen and oxygen as a way of whichever comes first in the periodic table. So since hydrogen comes first in the periodic table before oxygen, the name would be something along the lines of something hydrogen, ... and then something oxygen, ... right? And depending on how many hydrogens there are, or how many oxygens, you would change the prefix, something that's before hydrogen. So hydrogen has 2 atoms, right? So you say dihydrogen, and then oxygen only has 1. So all you do is you change the ending of the second atom to "ide." So dihydrogen oxide, right? You really don't need to say monoxide because there's really no need, but you could change it to dihydrogen monoxide. So over here. So dihydrogen monoxide, right? And that's simply how you name covalent compounds. You have to remember to add the prefix depending on how many of those atoms there are. The prefix for both atoms, of course. Mono and di are the prefixes, and ide, which is the ending. The prefixes are really not that confusing. If you want, I could write all of them down. Number 1 is mono. If there's 2 of those atoms, it's di. If there's 3, it's tri. Excuse my handwriting. 4, it's tetra. 5, it's penta. What is happening? 5 is penta. And 6 is hexa. 7 is hepta. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. Really good business program if you guys want to join. So that is how you name covalent compounds. So let's try naming a few more covalent compounds and see if you really get comfortable with it. Before we actually do that, if you look at the covalent compound we formed the covalent compound. It might be more familiar to you now that I say it. We formed H2O. We formed the covalent compound of water. Most of you may not know water by the name of dihydrogen monoxide, but that's what water is. It's 2 hydrogen molecules or atoms, and it's 1 oxygen molecule, and that's really how you name it. And a lot of these covalent compounds have more common names, like table salt is, I think, disodium. I forget the actual name, but it's table salt and a lot more common names. NH3 is ammonia. CH3, CO2H is also vinegar. So there's a lot of common names for covalent compounds. Now let's actually get into practicing naming a few covalent compounds. Let's say, for example, you have PCl5, right? So try not to look at the little guide over here. Try not to look over here. To name it, all you have to do is look at P. Well, P is phosphorus. So, and there's only one of P, so you have to write mono phosphorus. And since there is 5-chloride, you have to write penta, because 5 is pentachloride. Right? And that is simply how you name PCl5, or monophosphorus pentachloride. An exception, you could do this if you wanted, but in not all cases do you have to write mono if phosphorus is the first prefix. So you could simply just write phosphorus pentachloride, but it does not really matter. So that's the end of the video, guys. I hope you enjoyed. You learned something new. As always, if you have any comments or concerns, please feel free to leave it down in the comment section below, and I'll look to get back to you as soon as possible. And other than that, thanks for watching, guys.